Good day, students. Today we're going to talk about tangents and circles, the relative positions of lines and circles, the properties of tangents with circles, and the common properties in circles. We are going to start with the relative positions of lines and circles. A line that intersects a circle at one point only is called a tangent. As you can see in the figure here, the red line is intersecting the circle at one point only. This is why we call the line a tangent. Now, a secant line is a line that intersects the circle at 2 points. As you can see in the figure, the line is cutting the circle at 2 points, and I said the word cutting because the word secant in Latin is secare, and secare means cutting. So this line here is cutting the circle at 2 points. This is why we call it a secant. Now, a line doesn't intersect the circle at any point, and as you can see, if it's outside of the circle and it's not touching the circle at all, then we call it an exterior line. Now, let's look at the figure. Let C be the circle, okay? We can see that OM is the radius. And a quick reminder about the radius. A radius is a straight line from the center of a circle to a point on the circle. And a radius can tell you the circle's size. We are seeing here that OM is perpendicular to line B at the point of tangency M. What do we mean when we say perpendicular lines? Perpendicular lines are two different lines that intersect each other at 90 degrees or at a right angle. Okay, as you can see here, they usually intersect each other at a right angle, okay? So the tangent line is perpendicular to the radius, or the radius is perpendicular to the tangent line. Now, we look at the second figure. If M is exterior to C, then we can draw two tangent lines from C to M, MP and NP. Now, according to the tangent theorem, the two tangent theorem, two tangent segments or lines are equal because they are drawn to the same circle from the same external point. So what's the same external point here? It is M, and the circle, it's the same circle. We're drawing it from M to P and from N to T to the same circle. This is why, according to the two tangent theorem, these two tangents are equal. Now, OM is perpendicular bisector of PT. What does that mean? It means that OM, we will see it here in the figure, OM bisects PT at its midpoint. I will show you in my cursor. This is OM. It bisects PT at its midpoint in the center of PT. So, if you remember the perpendicular bisector theorem, it states that if a point lies on the perpendicular bisector, okay, of a segment, then it is equidistant from the endpoint of that segment. And this is why we deduce that segment OP and OT are equal. It means they are equidistant, or they are at equal distance, and they have the same measurement. Now we move on to the diameter and the angle. Any angle facing the diameter is equal to 90 degrees. And here in this figure, angle AMB, or if you want to call it angle BMA, is a right angle because it's facing the diameter. If you'd like to be reminded of what a diameter is a straight line passing from side to side through a center of a circle. Now, if you wish to find the measurement or the distance from A to B, which is the diameter, you multiply the radius by 2, okay? Because the diameter is 2 times the radius. If, for example, OB, which is a radius, is equal to 3, let's say centimeter, and we need to find AB, we multiply 2 by 3 and we get 6 centimeter, which is the measurement of the diameter. Now we move on to the second point. The radii of the same circle are equal. Radii is a plural of radius. So OB is equal to OA equal to OC. Why is that? We can say that all these radii are congruent because they are all the points on the circle are at the same distance from the center. Now, two circles having 2 points in common are called intersecting circles. As you can see here in this figure, we have circle C and we have circle C prime. These two circles intersect at 2 points, A and E. This is why we call them intersecting circles. Now, in the second figure, we have two circles, circle C and C prime. These two circles, they intersect at 1 point only, and this is why we call them tangent circles. If two circles do not intersect or do not have any common point, then we call them disjoint circles. As you can see in the last figure, they do not touch each other, so this is why we call them disjoint. They do not join at any point. Now, ladies and gentlemen, we're going to start with the assignment. I would like you to read the questions carefully. You have 4 questions, question 1, question 2, 3, and 4. I would like you to read them carefully and answer them on a white sheet. Okay, and best of luck. And if you need anything, please do not hesitate to contact us through WhatsApp.